Jai Hind. Everyone, I am from Indian Space Team PR Department. Today's we discuss about Earth hydrosphere and atmosphere. Have you ever wondered how much water is present on Earth and how it is distributed? Let's dive into the concept of Earth's hydrosphere to find out. The hydrosphere is essentially the sum of all water on Earth and its distribution. It includes the vast global ocean, water in the atmosphere, and water found on land. Now, when we talk about the global ocean, we're referring to an immense body of water, accounting for a staggering 1/4,400th of Earth's total mass. Covering an area that's about 3 times the size of Mars, with a mean depth of around 12,000 feet, the oceans hold an estimated volume of 1.3 billion cubic miles. Just imagine, if we were to smooth out all of Earth's surface to the same elevation, the resulting world ocean would be 1.7 miles deep. Now, not all water is the same. About 97.5% of the water is saline or salty, while the remaining 2.5% is fresh water. Most of this fresh water, around 68.7%, is locked away as ice in ice caps and glaciers. The rest is mostly found as groundwater, with a small percentage as surface water, such as in lakes and rivers. There's even water in other forms like permafrost, atmospheric water vapor, and biological binding. The distribution of this water in various forms is key to supporting life and maintaining Earth's climate. The hydrosphere interacts with other spheres of the Earth system, including the geosphere, atmosphere, and biosphere, in a complex web of processes, making our planet a unique and dynamic place. So the hydrosphere plays a vital role in supporting life and maintaining the Earth's climate. There's so much more to learn about our planet's water systems, so stick around as we continue our exploration in the next scene. Did you know that accumulated snow can transform into huge bodies of ice called glaciers? Fascinating, isn't it? But let's delve deeper to understand this intriguing process. In the chilliest corners of our planet, the snow doesn't just melt away when summer arrives. Instead, it morphs into ice, layer upon layer, year after year. Over time, these layers compress under their own weight, forming solid masses of ice that we call glaciers. Now, there are 2 main types of glaciers. Alpine glaciers carve their way through mountains, while expansive ice sheets cover vast tracts of land in the polar regions. These glaciers are not static, they're always on the move, albeit at a glacial pace. Driven by gravity, they flow like very slow rivers, reshaping the land as they go. They grind and gouge the surface, carving out U-shaped valleys and other stunning landforms. So, in their slow, persistent way, glaciers are powerful architects of our planet's landscape. While we're on the topic of ice, let's not forget about sea ice, another crucial component of Earth's hydrosphere. Think of the Arctic, where sea ice covers an area as vast as the United States. However, this icy expanse is rapidly diminishing due to climate change. As our planet warms, the Arctic ice cap is shrinking, impacting not just the polar ecosystem, but global climate patterns as well. So you see, glaciers and sea ice aren't just stunning spectacles of nature. They play a vital role in shaping our planet's topography and influencing its climate. They're integral to the Earth's hydrosphere, a testament to the power and beauty of nature, and a reminder of the urgent need to combat climate change. Glaciers and sea ice, thus, are not just beautiful natural phenomena, but also significant influences of our planet's landscape and climate. Ever wondered why seawater tastes salty and how this salinity affects our climate? Well, let's dive in to understand this fascinating phenomenon. The average salinity of Earth's oceans is about 35 grams of salt per kilogram of seawater. In simpler terms, that's about 3.5% salt. Now, you might be wondering where all this salt comes from. Most of it has been released from volcanic activity or extracted from cool igneous rocks over billions of years. But the oceans are not just vast saltwater bodies. They also serve as a massive reservoir of dissolved atmospheric gases, which are vital for the survival of many aquatic life forms. From the oxygen that fish breathe to the carbon dioxide absorbed from the atmosphere, the oceans are teeming with dissolved gases that play a critical role in supporting marine life. Now let's talk about the big role that these saline waters play in our climate. The oceans act as a giant heat reservoir, absorbing heat from the sun and distributing it around the world via ocean currents. This ability to store and redistribute heat makes the oceans a significant influencer of global climate patterns. Ever heard of weather patterns like El Niño or the Southern Oscillation? These are excellent examples of how shifts in oceanic temperature distribution can cause significant weather shifts. During an El Niño event, for instance, warmer waters in the Pacific Ocean can lead to increased rainfall in South America and warmer winters in North America. So you see, the ocean's salinity isn't just about making the seawater taste salty. It's a vital part of our planet's complex climate system. The salt in the ocean helps to drive ocean currents, which in turn influence weather patterns and climate around the globe. So, the oceans do much more than just provide us with a vast expanse of blue. They are crucial climate regulators. Does the abundance of water on Earth make it unique in our solar system? It's an intriguing question, isn't it? Let's dive into it. Earth is a blue jewel in the vast cosmos, swathed in a generous layer of water. This abundance, particularly of liquid water, sets Earth apart from its celestial neighbors. When we gaze out into our solar system, we find that while other planets with substantial atmospheres do host atmospheric water vapor, they lack the surface conditions necessary for stable liquid surface water. Take Mars, for example. The red planet does have traces of water vapor in its atmosphere and ice at its poles, but the low atmospheric pressure and frigid temperatures prevent the existence of persistent liquid surface water. Venus, Earth's other close neighbor, is far too hot for liquid water to exist on its surface. But it's not just the planets that we're interested in. Some moons in our solar system show signs of large reservoirs of extraterrestrial liquid water. Jupiter's moon Europa and Saturn's moon Enceladus, for instance, are believed to harbor vast oceans beneath their icy surfaces. These subsurface oceans might even hold more water than all of Earth's oceans combined. However, these oceans are hidden away beneath kilometers-thick layers of ice. This makes the liquid water inaccessible and therefore less influential on these moons' overall environments. On Earth, in contrast, water is a defining feature. It covers about 70% of our planet's surface, and it exists in all three states: solid, liquid, and gas. It's in our oceans, our atmosphere, our land, and even in us, the living organisms that inhabit this planet. It's a key player in Earth's climate, and it's essential for life as we know it. So, while water is not unique to Earth in the solar system, the abundance and accessibility of liquid water on our planet's surface certainly is. This liquid wealth, interacting dynamically with our planet's atmosphere, land, and life, shapes our world in ways that are unique in the solar system. This abundance of water is one of the factors that make Earth a special planet in our solar system. What makes up the air we breathe, and how does it vary around the globe? Earth's atmosphere is a dynamic and complex blanket of gases that surrounds our planet. It's composed predominantly of nitrogen, making up roughly 78% of the atmosphere. Following that, about 21% is oxygen, the gas we humans, and indeed all animals, need to survive. The remaining 1% is a mix of various other gases, with argon being the most abundant, and trace amounts of carbon dioxide and other gaseous molecules. The atmospheric pressure at sea level, which is essentially the weight of the atmosphere pressing down on us, averages at about 101 kilopascals. But don't worry, our bodies are perfectly adapted to handle this. Now, let's talk about water vapor. It's a key player in Earth's atmosphere. Although it only makes up between 0.01% and 4% of the air, its content varies significantly depending on geographical location and weather conditions. For instance, it's more abundant in warm, tropical areas and less so in cold, polar regions. And its role? It's crucial in the formation of clouds and precipitation, making it a vital component of Earth's water cycle. Speaking of clouds, these fluffy formations cover approximately 2/3 of Earth's surface, more so over the oceans than land. They reflect sunlight back into space, helping to cool the planet and also trap heat, contributing to the warming of Earth. Lastly, let's touch on the troposphere, the lowest layer of our atmosphere and where weather occurs. Its height varies with latitude, being thinner at the poles at around 5 miles high and thicker at the equator, reaching up to 11 miles. This variation is due to the heating effect of the sun, which is more direct at the equator and more oblique at the poles. Thus, our atmosphere, with its unique composition and variable features, is what makes life possible and diverse on Earth. Please share this video.